Good morning, my YouTube viewers, or good afternoon, I should say. It is Crystal here. I'm just here to do another code review. Last week, I did a code review on Kaggle's Playground Competition 3.2, and this week I'm doing a code review on Kaggle's Playground Competition 3.3, and it's Logistic Regression. And I just want you to know that I've used all of my 5 submissions for the day. So I've been working on this all day long and I've used all my submissions. So I decided I'd go ahead and do a code review on it and see how we go. So this is the playground competition. You can see I scored 85%, which wasn't really great. I think the highest score was 94 or 95%, but at least I got on the leaderboard, and I had improved from I think 81% to 85, and because previously I had used random forest because I was hoping that I could get a better score with random forest, so I was spending all this time on random forest, and then I just decided that I had one more submission for the day, so I decided I would use logistic regression and see if I could improve my score with logistic regression. And as it turns out, my score did improve with logistic regression, but I've used all of my attempts to submit my work for the day, so I can't do any more. So this is your problem statement. This data set for this competition, both train and test, was generated from a deep learning model trained on an employee attrition. Feature distributions are close to, but not exactly the same as the original. Feel free to use the original dataset as part of this competition, both to explore differences as well as to see whether incorporating the original and training improves model performance. So the first thing I did was I imported my libraries. So the libraries that we're using in this competition question are NumPy, which is for numerical Python, Pandas, which is panel data and it's for data processing, matplotlib.pyplot, SPLT as for visualization, and Seaborn for visualization with statistics. We also imported OS, which is for the operating system, to go into the operating system and retrieve files, and we also imported sklearn, which is the machine learning library. So after we imported our libraries, then what we wanted to do is we wanted to go into the operating system and retrieve the files that we were going to use in the competition. The 3 files that we were going to use in the competition are train, test, and sample submission. So after we retrieve these files, we use pandas to read the files. So we name the files train, test, and submission. So you can see we've got the train file, which is 1677 rows by 35 columns. The 35th column is the target, which is attrition. And then what we did was we checked the test, and the test is 1,119 rows by 34 columns. So it doesn't have a target column, which was attrition. So it doesn't have that. That's what we're going to be making predictions on. And then so it has a submission. And so what it wants in the submission is the target column is a bivariate or a bivariate, either a 1 or a 0. But the submission, it wants to be a float. So what I'm assuming is it's going to be using logistic regression. It's going to be using predict proba. It's going to be using the probability of attaining a certain value. That's what I'm assuming, because you're not going to be able to use linear regression. It's not a regression model and so you won't be able to use linear regression. So the only thing you can use is logistic regression, or logistic regression, which is a classifier, or another classifier that has predict proba attached to it. So we're going to analyze it. We're going to analyze the target. So this is the target, the attrition column, and as you can see, it has a class imbalance. So that's another thing that needs to be looked at as the class imbalance. We look at train info, so you can see that there's quite a few integers and objects and floats. So that's interesting. So all of these are either integers or objects. I don't think I see any floats in here. And then so we check for null values. There's not any null values. And so what we do is we combine our train and our test. So we take the target. The target is the attrition column in train. And our combi is train dot drop attrition axis equals 1, meaning it's a column dot append test. It's combi. And then so we look at combi, and so you see that we've got 2796 rows by 34 columns. So it doesn't have the attrition column. So now we check for any null values. We haven't got any null values. And so we drop the ID column. The reason why we drop the ID column is because it's not necessary, and the reason why is because all of the rows of data are indexed, and because all the rows of data are indexed, you don't need the ID column. And then now we check so it should be ID. It shouldn't have ID column anymore. We've dropped it. But we check for null values, and you'll see we've got null values. We don't have any null values. So now what we're going to do is we're going to check for unique values. I just wanted to see what unique values they had in all of the object columns. So you can see that. And so I can see over 18 is yes. And so that's interesting. Now we're going to check for the number of unique values. And so this tells you how many unique values you have in every column. So that's interesting. So over 18 has only one unique value. So you wouldn't need the over 18 anyway. So that's really interesting. So now we're going to ordinal encode all of the object columns. And so now all of the columns, they're all numbers, or they're all floats or integers. So now what we're going to do is we're going to create a heat map for all of the numeric columns, because all of the columns are numeric now. And you can see which columns have a high correlation to each other. If it's a light color, if it's like an amber or a white color, that means it has a high correlation to each other. So you can check the correlation here. You can see how all of the columns correlate to each other. So now we check for null values again. We don't have any null values. Now we remove all the columns that have a high correlation. And so now we only have 26 columns of data. So we've removed a few of those columns. We check for null values. We don't have any null values. Now we normalize our data, and this is where we came across some problems, because normalization equals combi minus combi min over combi max minus combi min. And then when we normalize the data, we got not a numbers. So that was problematic. So what I had to do was I had to look for all the null values, and you'll see that employee count was a null value, over 18 was a null value, and standard hours was a null value. So what I did was I dropped the columns that had null values. And because I didn't understand what was going on, why it had a null value, but it did. And so now we've only got 23 columns of data after we've dropped those 3 columns that had null values. Now what we're going to do is we're going to define our X and our Y variables. So Y is your target, X is your COM-B, 0 to the length of train, and X test is your COM-B, the length of train to the end. So now we're going to split the data set up into train and validation sets. And with those train and validation sets, we're going to break it up into X train and Y train. So you can see how we've done that. And then we can check the shape as well. Now we're going to look for null values, and we see that we haven't got any null values because I had to keep checking for null values, and the reason why is because when I selected my model, it went into error saying that there were null values, so I had to go keep checking for null values. But we did find out when we normalized our data, something happened when we normalized our data, and so 3 of the columns turned up null values, which it should not have done that, but that's what it did. So now we check for logistic regression. We check class weight is balanced, random state is 42, and I could have put it on grid search CV to try to get a better accuracy, but I have used all of my tries for the day. So that's one thing that we could have done to try to improve the accuracy, was to put it on grid search CV, but you know the class weight is going to be balanced because there's a class imbalance. But that's what we just did. We got 73% accuracy when we trained and fitted our X train, Y train. And then now we're going to predict on the validation set, and we've got 71%. And then we decided that we were going to define Y proba, which is going to be your predict proba. So this is your Y proba. And then we check our matrix. And so we had our confusion matrix. So you had 109 zeros, positives or zeros, and 44 ones when they should have been 0. And you had 11 ones and 4 zeros when it should have been 1. And now what we're going to do is we're going to predict on our test set. And we're going to say Y test proba equals model.predict proba X test. So you check your Y test proba, and then we prepare our submission. And so that's it. We prepare our submission. And there's another thing that I could have done because I was in such a rush, that what we could have done was we could have divided this into 2 and then see if that improved our score when we divided it into 2. But I've used all of my submissions for the day, so I can't do that. But if you want to go through and see if it improves your score, if you divide your Y test proba by 2, yeah, go right ahead and give it a try. And then we prepare our submission. Submission to CSV is submission index equals false. And then submission equals PD read CSV, submission.csv. And then we check our submission. And then so we have, this is what we submitted to Kaggle. So you could do it. There's a possibility if you want to divide it by 2, you could do it. But I've got an 85% using this, and you only allowed 5 submissions a day, so I couldn't do any more work on it today. So this is what I've done for the day. So I'm going to go ahead and conclude this video because I've done the code review. If you want to copy my Jupyter Notebook and see if you can improve upon it, then go right ahead. Be my guest and let me know what you did. See if you got a better score than me. So thank you very much for watching my video. Thank you to my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. I look forward to making more videos for you in the future.